All right, this is going to be the fifth and final lesson in this unit about quadratic graphs. Each of these word problems will have a quadratic graph. You'll be looking for lots of different points of entry on here. Let's just talk about those different points. One of the points might ask you to find the vertex up here. That would be something like how high did it go? How long did it take to reach that height? Could help you find that point. Another point that you might need to find is this one x-intercept, because that would be like when it hits the ground. How long did it take to hit the ground? The ground is 0. And so therefore, since the ground is 0, the x value would be how long it took to hit the ground. Another type of question might be asked is, it might ask you, when is it this particular number? That might be, let's say this is 9. So when is it 9 feet above the ground? And then what you could do is use your graph to figure out the two locations. Sometimes it may only cross once, sometimes it may cross twice, because it might cross 9 going up, and it might cross 9 coming back down. And so Desmos can help you to find each of these points, but you have to know what you're looking for. If you want to know when it hits the ground, you're looking for the x-intercept. If you want to know when it's at its maximum height, you're looking for the vertex. If you're wanting to know when it hits a certain number, like 9 on this one, then you would want to put two equations in so that you could see when it would hit the 9. So let's look at our first problem. Abigail tossed a coin off a bridge into a stream below. The height h in the feet is the coin is above the water is modeled by this equation. Negative 16t squared plus 96t plus 112. H represents the height, so it's equal to the height. T represents the time in seconds. What is the greatest height of the coin, and how much time will it take for the coin to hit the water? So the first thing you need to do with this, this is asking for two totally different things, but I think you can pretty much be able to get the answer from Desmos for either one of these. I'm going to take this equation with me if it'll let me. I guess I'll have to type the equation. All right, so, and make sure that when you're typing the equations, you don't type in the letters in the formula, you type in x's and y's. So y is equal to negative 16 x squared, and then we had plus 96x, I believe, plus, let's go back and look at the equation, make sure I'm getting the equation right, 96x and 112. All right, so there is my problem. And as you can see with this graph, you've got a tremendously tall graph for that 112, so we might need a different scale for some of these graphs. So one of the things you can do is you can come over here to this little wrench and you can set your scale. So right now it's from negative 10 to positive 10. Well, we probably don't need a lot of negative on this problem, so I think I'm going to put in -1 just so I have a little negative, to maybe 20. 20 seems too much. We'll put back that 10. But the height is the problem. So let's put in -1 so we have a little bit below the x-axis. And since we know that it's got to go, the y-intercept's 112 in this problem because that's the number on the end of your formula. You know you're going to have to go more than that. So let's just put in 200. And let's let it step by 20s. And if that doesn't work, then we can adjust it. Well, as you can see, I can't see with the 200, so I'm going to put in 300. Now I can see the top of my graph, so I think I've got my scale set up correctly. It's kind of like zooming when you do zoom 6 and zoom 0 and zoom 3, but on a graphing calculator you don't have numbers you can look at, and here we do. So I'm just going to shift it just slightly so we can see the whole graph. So one of the things I'd like you to do with this is I'd like you to take a picture of this graph, and then I would like you to label the graph with what you know about the graph. That helps to answer the questions. So let's go and take a picture of export. Let's see, I think that's what I want to do. Export the image. Well, actually, I might just take a picture of it because I have Smartboard, but you would need to export it because that way you would be able to bring it over and work with it. All right, so here is our picture. So let's first figure out what is it again asking us. It says, what is the greatest height of the coin? And that would be your vertex. Your vertex is always going to be the highest point on your graph, and that is always going to tell you when it's at its greatest height. So what is that height, and when did that happen? It could have asked you that. It didn't ask me when it happened, but it could have asked me that. Now that's where going back to Desmos and finding that point at the top and just clicking on it is 3,256. All right, so let's bring that over to our Smartboard document. Okay, the point is 3,256. And let's talk about what does that mean. Well, first of all, this was y, and these were x's in our problem. And so therefore, this is x, and x represents t in this problem, which is in seconds. So in 3 seconds, y in this problem represents h, and h is in feet. So therefore, in 3 seconds, it got to the maximum height of 256 feet. So that's what we're doing with this one in terms of what does that maximum height represent. And so the answer to the question is 256 feet, because that is the maximum height. Now the second question, which is behind my graph now, how much time will it take before the coin hits the water? All right. So when will it hit the water? Well, first of all, we tossed a coin. It went up for a little while, but then it came back down until it hits the water. So the water would be down here at this point, because that is the x-axis in this graph, and therefore when it hits 0, the x-intercept would be the answer for when it hits the water. So that looks like it's 7, but I'll go back over to the Desmos just to make sure. So if I click on this point right here, 7, 0. So let's bring that point back over to our 7, 0. So again, this is your seconds, and this is your height. So your height is 0 when it hits the water, and so it took 7 seconds to hit the water. So that's kind of what I'm asking you to do with these problems. I want you to pull that graph off of Desmos. I would like you to be able to take that graph and put it into your document so that you can label it with the points, and then after you've labeled it with the points, you'll be able to take that information and tell what it represents in terms of the variables that are actually in the problem. All right, let's try another. Okay, so in this problem, the profit that Mr. Lucky's company can make is represented by this equation, P equals. It says that it's profits in hundreds of thousands of dollars. So when you get what P is, and P is 3, that doesn't mean 3, it means 300s of thousands of dollars, so 300,000. And T is how many years he's been in operation. He realizes his company is on the downturn and wishes to sell before he ends up in debt. When will Mr. Lucky's business show the maximum profit? What is the maximum profit? And at what time will it be too late to sell his business because he'll start to lose money? So we need to type this equation into Desmos. Again, you don't type P's and T's, you type the actual y and x for those. So y equals -3 x squared, and I have to go back because I don't remember what the problem was, 18t minus 4 plus 18x minus 4. Make sure that's right. Yeah. Okay, here we go. So again, we probably need to change our scale because the last one was a really tall problem. This one's not. But I can see it probably is not going to go more than 30. So I'm going to leave the x-axis alone. But I am going to change the y-axis from -1 to about 30 by 5s. Let's see if that works good. And it does. So therefore, we will capture this picture. Again, you need to capture it a little different way. I'm taking a picture of it. But what you need to do is come over here to this point. Say you want to export the image, click medium at least, hit the download button, and it will go to your drive. All right, so let me make this picture just a little bit smaller. All right, so let's talk about these points on here in terms of his problem. Well, and actually, we probably should have looked at more of the negative part of this graph. So let me go back to Desmos here for just a second and move this graph around just a little bit. All right, let's talk about the y-intercept here for just a moment. So what would that y-intercept represent? Well, if you remember, this is T and this is P. So at time 0, when he set his business up, he is $400,000 in debt, because remember, it's in hundreds of thousands of dollars, and -4 would mean he's in debt. So he gets out of debt here. And that's how much time it takes him to start making a profit. So it's not even in the first year. I mean, it didn't even take him a year and he starts making a profit. And then he makes a profit till he gets to here. And at this point, up here at 323. And then down here is when he stops making a profit. So we need these values. So I'm going to bring these values over and write them down on my graph. So down here, this is 0, -4. This point here was 0.213, 0, I believe. This one was 3,23, I think. And I forgot what this one is, so I'm going to go back and get that one. 5,769. 5,769. 5,769, 0. Now let me make sure I got all those right. 0.4, 0.231, 323, and 5.769. All right. So now let's see if we can figure out what this problem is asking for. When is Mr. Lucky's business showing the maximum profit? Well, maximum profit, this is our maximum. Remember that these were our X's and these were our Y's. So this represents time and this represents profit. So when did he make a profit is at the maximum amount. His max profit happens 3 years in 3 years. What is that profit? Well, 23 is not how much profit he made. It's 2,300 thousandths. Okay, so 2,300 thousandths would be this number, I believe, because you take 23 times 100,000 to figure out what your number is, and that would end up being $2,300,000. So that's how you figure out how many hundreds of thousands it is. And then, when will it be too late to sell his business? When will he start losing money? Well, he started gaining money. Remember, we talked about this in the y-intercept is when he started the business and he started making a profit at 0.231, and he makes a profit as long as he's above the y-axis, because that's when he's making zero profit. So over here on the other side, this 5,769, 0 is when he stops making a profit. So he needs to sell his business before it gets to that time period, because after that he's losing money. So he needs to sell before 5.769 years. So basically, he needs to sell before it gets 3/4 of the way through that 6 year, and he will be able to sell his business at a profit. Now, if he wants to sell it when it's doing really well, he wants to sell it somewhere between year 3 and year 5.769, because that's when he's made his most profit. It'd be best to sell it when 3 years, but he can't sell it after 5.769 or he'll lose money. And he can't sell it before, or not before 0.231 years. Because if he sells it before then, so if he starts his business in a month or two, he will have, that first couple of months he's still not making a profit. So he has to make sure he waits until after he starts making a profit to sell it. All right, so that's what you do with those kinds of problems. Now we're going to look at some problems called consecutive integers. And these are products of consecutive integers. I know you've probably worked with, in Math 1, the sum and difference of consecutive integers. Well, first of all, consecutive integers are integers that go up by 1. So like, if the first one is x, then the second one has to be 1 more. So it's x plus 1. It says the product of 2 consecutives. So I have 2 consecutives written down. One is just one more than the next one. Product means to multiply. So I'm asked to multiply x times x plus 1. Is means equals, and I want it to equal 1640. Now I don't need to multiply that out, although if you want to, you can, but you do not need to multiply this out. We are using Desmos to solve these problems, so therefore it's not necessary. So in Desmos, we will put x parentheses x plus 1 parentheses, and I think that it would be best to probably put the 1640, was that the right number? Yeah, 1640. I think it would be best to put that in the second line. And now we're going to go up here to your wrench, and we're going to fix the maximum to be like 1700 so we can see it. And I'm going to go by 200s. All right, and I don't see anything. All right, well, let's put a y equal to in here. Maybe we need the y equal to. Okay, there we go. Now I didn't set my x's, so obviously I'm going to need to set x's as well. So since I have no idea what the answer is, I think I'm going to go from negative 50 to positive 50 just to get started and go by tens. Okay, now I can see something. So we have a couple possibilities here. One is negative 41 and the other one is 40. Now, those two answers do not go together. So let's talk about how do you take these two answers, come back, and make the answers to the question. So if x is equal to negative 41, or if x is equal to 40, maybe we should talk about 40 first. Okay, if x is equal to 40, what would the next number consecutively after 40 be? Well, it'll be x plus 1, which is 41. And if you multiply those two numbers together, you should get the answer 1640. Now, what would x plus 1 be if the number is a negative 41? Well, negative 41 plus 1 is negative 40. And so therefore there are two possible answers to this question. There's a negative answer because a negative times a negative makes a positive 1640, and a positive times a positive makes positive 1640. All right, let's look at even and odd ones now. What do odd numbers go up by? Like 1, 3, 5, 7 are odd numbers. They go up by 2's. What do even numbers go up by? 2, 4, 6, 8. They go up by 2's. So the product of two of them, my first number and my second number, would have to be x and x plus 2, because you want it to go up by 2 so you get every other number. Whether it's odd or even doesn't matter, because odds go up by 2's and evens go up by 2's. So this pattern has to go up by 2's. So x and x plus 2 is equal to 1150. All right, let's try that in Desmos. I'm just going to go in here and change that one number to a 2. And then I'm going to change this number. And that number was supposed to be 1150. All right, so I can use my scale from the last time. I want to know where these two intersect. And so here are my places. This one does not have quite as nice of an answer as the last one did. Did I type the number wrong? 1150. No, it sure doesn't. Well, let's try number 5. We'll come back and look at that one in a minute. I might have a typo on that one. All right, so in number 5, your first number and your second number for even are just like odd. If the x is the first one, then x plus 2 is the second one. And then we're looking for the product again. See product? So you're doing x times x plus 2 is equal to 224. All right, let's try this one, see if it's any better. All right, so here's where it intersects. Yeah, this one's much better. So we'll look at this one. I'll go back and figure out what's wrong with that other one in a minute. So in number 5, you have two possibilities, negative 16 and positive 14. And so we can take that back to the PowerPoint. All right, so x is equal to negative 16 and x is equal to 14 was our two possibilities. Let me double check that. Yes, that's correct. I don't need to write it as a point because the 224 is what the problem is equal to. I just need those x values. So if x is that, then the key here is what would x plus 2 be? Well, if you add 2 and negative 16, you get negative 14. And if you wanted to check this, you'd multiply those two numbers together. Negative 16 and negative 14 would make a positive number. And it probably makes 224 if we've done the math right. And then with x plus 2 over here, if you add 2 to 14, you get 16. So 14 times 16 also makes 224. All right, I went back to the document in my workroom to find out what was wrong with number 4, and it was a typo. It's supposed to be 1155, not 1150. So if it's equal to 1155, you'll get a decent answer. So let's go back and find that answer. And I'm going to have to change my window because I've messed with it on these last two questions. I changed it to 1155, but I can't see the whole window. So let's go from like negative 50 to maybe positive 100. I'm not sure if that's going to do it or not. Let's go by tens. Let's see. Yep, that did it. So when you click on these 2 points, you get decent points now. And your numbers for these problems really should be nice. So if you come across one that's not, please let me know. I can always send out a correction for these. Sometimes people have opened the documents in a workroom and accidentally changed a number, and I didn't realize this one that had happened. So 1155 happens at negative 35 and positive 33. So let's take those answers back over to our document here. So if x is equal to, well, I forgot what they were, negative 35 and positive 33. Negative 35 and positive 33. So if x is negative 35, if you add 2 to that to get the next positive or negative number, you know, you've got to know how to work with it with the negatives. It's a little bit different. So if you add 2 and negative 35, you get negative 33 because you're going up the number line 2 numbers. And if you add 2 to 33, you get 35. So what ends up happening with these is a lot of times the negatives and the positives switch around which number comes first, but they both have to be negative, they both have to be positive to multiply to be a positive number. All right, we have one problem left, and then this one's more related to word problems, so bringing that graph back over and writing the information will be very important. You're making business plans for a pizza fundraiser for the band boosters at Roosevelt High School. Figured out that how to both sales and income and selling expenses would probably depend on the number of pizzas sold. So they predicted the income and the expense formulas. Write a formula that represents profit formula for these functions. When will the profit break even? When will the profit be at the max? Describe the amount of profit over time. So let's see what we can do with this. First of all, if you have income, that's the money coming in. If you have expenses, that's the money going out. So if you have $500 coming in and $20 going out, the difference in that would be your profit. So I need to take these formulas and say profit is equal to income minus expenses. So my profit P of N formula is going to be equal to, and I would put these in parentheses since there's more than one term, negative 0.05 N squared plus 20N minus 5N plus 250, parentheses. So you put those in parentheses and say you want to subtract them. Now you don't have to do any of that math. And that's the key to this. Let the calculator, if you're going to use a calculator to do the math, don't do anything to your formulas. Type your formulas the way they are, okay? Now, the difference in these is your profit. So what does it mean to break even? Well, break even means you didn't make any money, but you didn't lose any money. So that would be when you're making zero profit. And maximum profit is going to look like a maximum on the graph. So if we can type this formula into our calculator, we should be able to look at a graph of this, and we want to make sure we can see the x-axis. We want to make sure that we can see maybe the maximum at the top, so we'll have to set our window again. All right, so first we're putting in a y=2 formula, and we're putting in parentheses -0.05, -0.05 x squared plus 20x parentheses minus parentheses 5n plus 250. 5x plus 250 parentheses. I don't quite have those parentheses right, so let me correct that. And I don't have quite right over here either, because it did something funky about typing in parentheses. All right. Well, I'll start again. It deleted it. Y equals parentheses point negative 0.05 x squared plus 20x minus, you don't have to put the back parentheses, it puts it for you if you get out of it. Okay, 5x plus 250. And I got two equal marks, so let me take and fix that. Okay, the formula looks right. So now let's see what we can do over here. We need more x. So I'm going to set this up to be like -20. Well, too many zeros. -20 to like 150 by 10s. No, it didn't take the 5. Okay, and then here I'm going to set it up to be -300 to, I'd say probably 1,000 by hundreds. All right, here we go. Well, I don't quite have enough x, so let's get that x going up more. Let's say 300 by 50s. There we go. Now we can see it all. So in a word problem, you always want to start with the y-intercept, because that y-intercept represents, well, it didn't put it on the y-intercept. Let me see if I can just click it. There we go. Because the y-intercept represents what you started out at. So when you started this, you were going to be -250. That means you're $250 in the hole, because you had to put out some money to pay for the pizzas. This point here is when the amount of time it takes to get to profit is 0. This here is, of course, is your maximum. And this one over here is another place where your profit equals 0. So, for example, if I describe this whole graph in terms of my problems, let me take a picture of it so I get all these points and bring it back over. All right, now let me make it a little bit smaller so we can see it. All right, so let's start with the first question. When will profit break even? So when is the profit 0? Now remember that these formulas, when you have something in function notation, this is y and this is x. So n is your x and p is your profit. N is the number of pizzas. So this is how many pizzas you would have to sell. So when you have sold 0 pizzas, you're negative $250 in the hole because you bought all these pizzas and you haven't sold any. But when the profit is 0, that means you're on the x-intercept. So you break even when you've sold 17.712 pizzas or 282.288 pizzas. Now I know we can't buy a part of a pizza, but that's what the numbers are. So you would have to sell 18 pizzas or 282 pizzas and you would be making a profit, but if you sell these two numbers, you're breaking even. Now, what's the question behind here? When will the profit be at the maximum? Well, when will that happen? When you've sold maximum. Let's talk about this point. What does this maximum point mean? So this is N and this is P. So when you sell 150 pizzas, you will make $875 in profit. And that is the most you're ever going to make on this particular fundraiser. So you would not want to really buy any more than 150 pizzas because you will not make as much profit. So now it's to saying describe the profit over time. And describing your profit over time really is talking about these different well, it's really describing, when it says over time, it doesn't really mean time, it means your number of pizzas. So when you sell from 0 to 17.712 pizzas, you're in the hole. From 17.712 to 150 pizzas, your profit is increasing to 875 at the most. And then from 150 to 282.288 pizzas, the profit is decreasing. Decreasing to 0. And then last but not least, after 288.288 pizzas, you're losing money. So that's what it means, like over time. Doesn't make any difference on how much time it takes to sell them. It's how many pizzas you're selling. So your best bet is to sell anywhere between 18 and 150 pizzas because you'll make money. And anything over that, you're not going to make any more money. So there's no reason to buy more than 150 pizzas. You've saturated the market and won't be able to sell them. So now you have some samples to do the same. If it's a word problem that is about a situation, I'd like you to put the graph with it and label it all. If it is one of these problems like the consecutives, you just write out the formulas and information like I did. You don't have to put the graph over here with it. You just have to put what X is and tell what the other number is, and if it has two answers, show both answers. So this is the end of the lesson's notes. So you now will be able to work on it and hope you have good luck with this. If not, let me know.